Hey, in this video I'm going to show you how to create a custom Revit family for load distribution plates and how to place them efficiently between vertical joists and binders using Rhino.Inside.Revit. Before we jump into modeling, let's briefly look at why these plates are so critical in timber construction. As you know, timber is an isotropic material. It means that it has different characteristics in different directions. This slide is part of my research for an extension of a single-family house with a green roof. As shown here, timber is very strong when pressure is applied parallel to the grain, but significantly weaker when pressure is applied perpendicular to the grain or the fiber direction. If we look at the fundamental stress formula, sigma equals to applied force through area, we see that to reduce stress, or sigma, we need to increase area, or the contact area in this case. And to increase the contact area between vertical joists and horizontal frames or binders, we use load distribution plates. Now let's look at the Revit model. Here is the extension of the single family house with a green roof, and here are my load distribution plates. Here is my binder and my vertical joists. If I choose one of the load distribution plates at the property panel, we see the parameters that I defined in the Revit family. Its structural length, that's this one, structural width here, and thickness, structural thickness. To make this family, you use generic model. I won't model the entire family from the scratch, as there are no complicated geometry cuts or calculated parameters. But as you can see, if we open this family, it is structured with simple reference planes and basic parameters, structural width and structural length. And the insertion point is going to be at the cross section. That's important. And for the extrusion, we assigned a parameter structural thickness. And the parameters are instance parameters, and that means that we can change them through the script. Now that we know how the family is set up, let's switch back to the project model and look at how Grasshopper controls their placement. The placement of each plate is directly dependent on the location of the vertical joists. I won't go through the framing script today, as I have already covered that in my video series Rhino Inside for traditional design, which focuses entirely on working with timber framing in Rhino Inside. Here is my script for load-bearing walls. It might look a bit complicated with a lot of nodes at first glance, but it really isn't. Using Rhino Inside instead of manually placing timber elements in Revit can easily save you between 50 to 70% of your modeling time. Inside Grasshopper and Revit menu, you have add component location, and that's the component we use to place load-bearing plates. Here is my script for the load-bearing plates. Here is the component, add component location, and this component wants location, and location is the point, and then component also wants the type, and the type is our family. In my case, I called it GP. It stands for just parametric construction stud bearing plate, or you can call it stud bearing plate or load distribution plate. It's the same. And to find the exact coordinates for each plate, we extract the location lines. I show you the location lines in Revit model. Here are the location lines for each vertical joist. So we extract the location lines for vertical joists, and then we extract the endpoint for each line. And here are the lines. Let's see if you can see them in the model. Actually, it's only one line. Here are the lines, and we find the endpoint, and then you just shift the points into the position using a standard move component. Once those points are set, you connect them to this L input value in add component location and choose the type, and then Rhino Inside will distribute the plates into the right position. That's all for now. Thank you for watching.